So last class I discussed about the definition of Z transform. So Z transform of Un is defined as summation Un z bar minus n, where n varies from 0 to infinity. Even if you don't write the limits of summation, it is understood that n varies from 0 to infinity. So there are two notations for any transform. So here you have one notation with respect to Un, that is z of Un, and other notation with respect to the kernel z, that is u bar of z. So z of Un or u bar of z is defined as summation Un z bar minus n. So last class I discussed the transform of standard functions a bar n minus a whole bar n 1 minus 1 whole bar n, the constant a, e bar a n, e bar minus a n, e bar minus e bar a n, minus e bar minus a n, cos h n theta, sin h n theta. So I discussed up to n bar 4. You should by heart all these transforms. You should have the formula page when you do the problems. You should remember the transform of all these standard functions. As you remember the derivatives of standard functions, you should remember the transform of standard functions, Z transform of standard functions. So if you don't know the transform, you cannot do any problem. So by heart all these expressions, practice writing these formula so that you don't forget. Now we will get into the properties of Z transform. You don't have to learn the proof for any of the properties. You only have to remember the statement. You don't have to learn the proof for any of the properties. You only have to remember the statement. So if alpha and beta are constants, Un and Vn are the nth term of the sequences Un and Vn, then Z of alpha Un plus beta Vn is alpha times Z of Un plus beta times Z of Vn. So transform of the sum equals sum of the Z transforms. Then you have the damping rule, exponential damping rule, shifting rule, initial value property, final value property. So I will take up the problems from every property. So the first property is very simple. By default you will be having in all the problems. So I will take up problems from the other properties. So you should remember the statement of all the properties and all the standard functions. So I will explain one by one. So type 1. So find the Z transform of 2n plus sin n pi by 4 plus 3 per n. So type 1, you will not be using any of the properties. So it is a direct question. Just you have to find the transform. So z of 2n plus 5 sin n pi by 4 plus 3 per n is 2 times z of n plus 5 times z of sin n pi by 4 plus z of 3 per n. So you are using linearity property here. Transform of the sum equals sum of the Z transforms. So what is z of n from the formula page? Z by z minus 1 whole square. What is z of sin n theta? You see here, z sin theta by z square minus 2z cos theta plus 1. So in place of theta you have pi by 4. Z sin theta by z square minus 2 cos theta plus 1. So in place of theta you have pi by 4, and z of a per n is z by z minus a. So z of 3 per n is z by z minus 3. So then you have the simplification. So the first term 2z by z minus 1 whole square. So sin 45 is 1 by root 2. So z into 1 by root 2 by z square minus root 2z plus 1 plus z by z minus 3. So this is the transform of the given nth term. So Z transform is only for the nth term. Okay, have that in your mind. Z transform is only for the nth term, Un. So now we have another problem, cos of 2n minus 3 theta. So whenever you have cos of a plus or minus b, sin of a plus or minus b, you make use of the formula. So cos of a minus b is cos a cos b plus sin a sin b. So I am taking z of cos of 2n minus 3 theta is z of cos 2n theta cos 3 theta plus sin 2n theta sin 3 theta. So now here cos 2n theta sin 2n theta are the nth terms, but cos 3 theta sin 3 theta are constants. I repeat, z of cos of 2n minus 3 theta is z of cos a cos b plus sin a sin b. So cos 2n theta sin 2n theta are the nth term, cos 3 theta and sin 3 theta are the constants. So cos 3 theta into z of cos 2n theta plus sin 3 theta into z of sin 2n theta. That is why the constants are taken out. Transform is only for the nth term. If you have the constant term, you have to take it out. So cos 3 theta into z of cos 2n theta plus sin 3 theta into z of sin 2n theta. So what is z of cos n theta? Z into z minus cos theta by z square minus 2z cos theta plus 1. So in place of theta you have 2 theta. What is z of sin 2n theta? Z sin theta by z square minus 2z cos 2 theta plus 1. In place of theta you have 2 theta. So then comes the simplification. So the right side, the denominator is same, so you can group the numerator. So z square cos 3 theta minus z cos 2 theta cos 3 theta plus z sin 2 theta sin 3 theta. So if you take minus z out, it is of the form cos 3 theta cos 2 theta minus sin 3 theta sin 2 theta. So it is of the form cos a cos b minus sin a sin b. So what is cos a cos b minus sin a sin b? It is cos of a plus b. So that is cos phi theta. So you have z square cos 3 theta minus z into cos phi theta by the denominator. So I repeat, the transform is only for the nth term. If you have constants, you should take it out. So here we have used the formula of z of cos theta, and here we have used the formula of z of sin theta. So we have replaced theta by 2 theta. So you should have the formula page in your hand, then only you can do the problems. See, here you have the transform of cos n theta. There we have found cos 2n theta. That is why we replace theta by cos 2 theta in both numerator and denominator. Then you had sin 2n theta. So this is a transform of z of sin n theta. Z of sin 2n theta, you just have to replace theta by 2 theta. So that's what we have done here. Now we will get into the problems using damping rule. Find the z transform of a power n by n. See, what is damping rule? Z, it will have a product un a power minus n or un a power n. If you see the problem, it will be either of this type, a power n un or a power n minus un. So z of a power minus n un is u bar of az. Z of a power n un is u bar of z by a. So just by looking at the term, you can easily identify the damping rule. It is of the form a power n into un, a power n into 1 by n. What is the formula? U bar of z by a. So take it as 1. You have to, where u bar of z, what is u bar of z? Z of un. What is un? Z of 1 by n. I repeat, when you see the expression a power n by n, so it is of the form a power n into 1 by n. So what is the transform of a power n un? U bar of z by a. So take it as 1. Transform of a power n 1 by n is u bar of z by a, where u bar of z is same as z of un. What is un here? 1 by n. See, they both are same. I told you you have two notations for transform. So so z of un. What is un here? Z of 1 by n. So we have to find z of 1 by n. So what is the definition? Z of 1 by n, it is not a standard function. You know the transform of n, but not 1 by n. So start with the definition. What is z of un? Summation un z bar minus n. In place of un, you have 1 by n. Expand the summation. So you have to omit n equals 0 because it is indeterminate. I am leaving the term n equals 0 because 1 by 0 is infinity. So I am taking the summation from n equals 1. So z inverse plus z power minus 2 by 2 plus z power minus 3 by 3 plus z power minus 4 by 4 plus etc. So if you have this series x plus x square by 2 plus x cube by 3 plus etc., it is same as minus log of 1 minus x. So you just by heart this step. It is same as, this series is same as minus log of 1 minus z inverse, or minus log of 1 minus 1 by z, or minus log of z minus 1 by z, or log of z by z minus 1. I repeat, you z of 1 by n, start with the definition, summation 1 by n z power minus n. You leave the first term because you are getting infinity. So when n is 1, z inverse. When n is 2, z power minus 2 by 2. When n is 3, z power minus 3 by 3 plus etc. So just by heart this step. This series is same as minus log of 1 minus z inverse. This series is same as minus log of 1 minus z inverse, or minus log of 1 minus 1 by z, or minus log of z minus 1 by z, or log of z by z minus 1. So we have u bar of z, that is z of 1 by n, as log of z by z minus 1. But what is the answer? U bar of z by a. Remember, in damping rule, the solution is u bar of z by a. So how do you get u bar of z by a? Only through u bar of z. So we have got u bar of z as log of z by z minus 1. Now u bar of z by a. So just replace z by a. So you will get log of z by a minus 1, or log of z by z minus a. So remember, in damping rule, the solution is u bar of z by a. So whenever you have a power n un, the solution is u bar of z by a. You have to find u bar of z by a through u bar of z. So find u bar of z, then replace z by a. So this is the answer for the problem. Now we have a problem from second damping rule, n square a power minus n. So it is of the form a power minus n un. See, there are two forms of damping rule. A power n un or a power minus n un. Easily you can identify. So here n square a power minus n. So it is of the form z of a power minus n un. What is the answer? U bar of az. So the u bar of az is the answer. You have to find u bar of az through u bar of z. What is u bar of z? Z of un. What is un? N square. What is z of n square from the table? Z into z plus 1 by z minus 1 whole cube. The n square is a standard function. What is a transform of n square? Z into z plus 1 by z minus 1 whole cube. So we have got u bar of z. The answer is u bar of az. So just replace z by az. So u bar of az equals az into az plus 1 by az minus 1 the whole cube. Now we have problems from exponential damping rule. So in place of a, you will have e power a. That is the only difference. Now we will see two problems from exponential damping rule. In place of a, you will have e power a. You see here, in place of a power minus n, you have e power minus an. In place of a power an, you have e power an. So we will see one problem from both the types of exponential damping rule. So the first one, e power an cos h n theta. So from the problem you can easily identify. So it is of the form z of e power an un. What is the formula? is u bar of z by e bar a. So you take it as 1. You have to get the answer through u bar of z. What is u bar of z? Z of un. What is un? Z by e bar a. What is un? What is u bar of z? Z of un. What is un? Cos h n theta. See, u bar of z by e bar a is the answer. We have to find through u bar of z. So what is u bar of z? Z of un. What is un? Cos h n theta. So what is a transform of cos h n theta? Z into z minus cos h theta by z square minus 2z cos h theta plus 1. This is a standard form. So u bar of z by e bar a. So just replace z by e bar a. You should replace z by e bar a. So z by e bar a here, z by e bar a here, z by e bar a whole square here, 2 times z by e bar a cos h theta plus 1. Then comes the simplification. So numerator you have e power 2a in the denominator. Denominator also you have e power 2a in the denominator. So it gets e power 2a gets cancelled. So you get u bar of z by e bar a as z into z minus e bar a cos h theta by z square minus 2z e bar a cos h theta plus e bar a the whole square. So we have got this answer. U bar of z by e bar a is the answer. So this is the answer. Now we have another problem from the second damping rule. E bar minus a n sin n theta. So whenever you have product, it will be damping rule. Whenever you have to find transform of a product, it is from damping rule. So start with the property z of e bar minus a n u n equals u bar of e bar a z. So in place of un you have sin n theta. So z of e bar minus a n sin n theta equals u bar of e bar a z. So u bar of e bar a z is the answer. What is u bar of z? Z of un. What is un? Sin n theta. What is the transform of sin n theta? Z sin theta by z square minus 2z cos theta plus 1. So u bar of e bar a z, just replace z by e bar a into z. Replace z by e bar a into z. So e bar a z sin theta by e bar a z whole square minus 2 e bar a z cos theta plus 1. So this is the answer. Now we have n minus 1 whole cube. So I have taught you problems from damping rule. Now we will look into problems from shifting rule. So you have two shifting rules, un minus k and un plus k. From un you have to find un minus k or un plus k. So I will do one problem from un minus k and un plus k. So first I will take a problem from un minus k. So n minus 1 whole cube. So whenever you have n minus k form, n minus 2, n minus 3, n minus 5, write the shifting property. What is it? Z of un minus k equals z power minus k z of un. So what is k here? 1. So what is un minus 1? N minus 1 whole cube. So if un minus 1 is n minus 1 whole cube, what is un n cube? So delete minus 1. See, if un minus 1 is n minus 1 whole cube, what is un? It is n cube. I repeat, whenever you have n minus something, n minus 1, n minus 2, n minus 3, you make use of the shifting property. Z of un minus k is z power minus k, z of un. So k is 1 here. So un minus 1 is n minus 1 whole cube. Un, delete minus 1, so you will get n cube. So what is z of n minus 1 whole cube? Z power minus 1, because k is 1, into what is un? N cube. So z of n cube. So z of n cube is a standard function. So what is z of n cube? Z into z square plus 4z plus 1 by z minus 4. So that's what you have here. So I repeat, z of, you see the form n minus 1 whole cube. So it is a shifting property z of u n minus k, z power minus k z of u n. So find k from this, k is 1. So z of n minus 1 whole cube is z inverse z of n cube. If u n minus 1 is n minus 1 whole cube, what is u n? Delete minus 1, it is n cube. So z power minus 1 into z of n cube. Z of n cube is a standard function. So you have this answer. Now we have next problem, n plus 1 whole square. So whenever you have n plus or minus k, it is shifting property. So n plus 1. So you see here, in n plus k, you have three forms. You should remember by heart these three: z of u n plus 1, z of u n plus 2, z of u n plus 3. So this is a formula in general, but in problems you will come across z of u n plus 1, z of u n plus 2, z of u n plus 3. So by heart these three. So here you have n plus 1 whole square. So it is n plus or minus k means shifting property. So z of u n plus 1, z into u bar of z minus u naught. So I have given the formula here. Z of u n plus 1 is z into z of u n minus u naught. So that's what I have written here. So u n plus 1 is n plus 1 whole square. U n, delete 1, so it is n square. So z of n plus 1 whole square is z into z of n square minus u naught. So u bar of z is z of u n. What is u n here? N square. What is z of n square? Z into z plus 1 by z minus 1 whole cube. If u n is n square, u naught is 0. So you have this answer. I repeat, see, whenever you have n plus or minus k, it is shifting property. So here you have n plus type. So u n plus 1. So write the formula. Z of u n plus 1 is z times u bar of z minus u naught. So what is u n plus 1? N plus 1 whole square. What is u n? N square. What is u naught? 0. So z into z of n plus 1 whole square equals z into z of n square minus u naught. Okay, so u naught is 0. So what is z of n square? Z into z plus 1 by z minus 1 whole cube. That's how you have this answer. Next we have cos of n plus 2 theta. So again you have shifting property, n plus 2 type. So write the formula. N plus or minus k means shifting property. N minus k or n plus k, shifting property. So z of u n plus 2. What is the formula I have given here? Z of u n plus 2, z square into z of u n minus u naught minus u1 by z. So if it is u n plus 1, it ends with u naught. If it is u n plus 2, it ends with u1 by z. If it is u n plus 3, it ends with u2 by z square. So here you have z square into z of u n plus 2 as z square into z of u n minus u naught minus u1 by z. So what is u n plus 2 cos of n plus 2 theta? What is u n cos n theta? So z of u n plus 2 equals z square into z of cos n theta minus 1. U naught is cos 0 is 1. u1 cos theta. If n is 0, cos 0 is 1. If n is 1, cos theta. So in the next step, z square into, you know the formula of z of cos n theta. It is a standard function. Minus 1 minus cos theta by z. So this is the answer. Now for this problem, you can even do cos of a plus b. You know the formula for cos of a plus b, cos a cos b minus sin a sin b. That way also you can get the answer. So but as far as possible, make use of shifting property. It will save time. See, if whenever you have cos of a plus or minus b or sin of a plus or minus b, you can make use of the formula. But more than the formula, using the shifting property will save time. So you go for shifting property. Now, if you make use of cos of a plus or minus b formula, it will take more time. That's it. Even for sine, you can use sine of a plus or minus b formula. It will take more time compared to using shifting property. Now next one, we have 1 by n factorial. So it is start with the definition. It is not a standard function. Start with the definition. What is a standard definition? Z of un summation un z bar minus n. So what is un here? 1 by n factorial. So expand the summation. If n is 0, 1 by 0 factorial, z bar minus 0, 1. If n is 1, z bar minus 1. If n is 2, z bar minus 2 by 2 factorial. If n is 3, z bar minus 3 by 3 factorial plus etc. So it is of the form 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial plus etc. So it is same as, in place of x you have z inverse. So it is same as e power z inverse or e power 1 by z. So this series, you by heart this, the transform of 1 by n factorial is same as e power z inverse or e power 1 by z. You will be using this in problems. So you should remember the transform of 1 by n factorial as well as 1 by n. You will be using in problems. See, in today's class I have discussed problems from type 1. Type 1 is a direct question. You will be getting the transform using the standard functions. Type 2 I have done problems using damping rule, that is properties. Type 2 I have done one problem from each of the damping rules, one here, one here, one here, one here, and then I have done one problem from un minus k. This is simpler, so that's why I taken only one problem. For un minus k you have only one form, so it is very simple. But un plus k, you should remember z transform of u. This is in general, but in problems you will be using z of un plus 1, z of un plus 2, z of un plus 3. So by heart these three. So practice writing the problems. You start with you should be thorough with the definition. So start with the definition, practice writing the proof of standard functions, by heart the transform of all standard functions, then have the formula page in hand and then practice the problems. You will find it easy to understand. Then you do without seeing the formula page. For the first attempt, first time you can work out the problem seeing the formula page. Then second time you try, after that you by heart all the formula. Then second time onwards you try to do without seeing formula page and then cross check the answer. So that way you will understand very well. So this Z transform is easy compared to Fourier transform. So you can easily get full marks in this topic.